We're going to talk about recursive calls. We're going to talk about recursive calls. See what I did? Oh, that's a terrible joke. I watched your common mistakes video. I did a video a while ago about common mistakes people make in their application development. And you mentioned that recursive calls are very bad. How do I detect them and how do I fix them? Here's the interesting thing. When I did my common mistakes video, it was about a particular element that you would detect as bad practice by looking at the recursive calls count for that particular facet. Recursive calls just carte blanche cannot be treated as that's bad because it depends. Now, detection is easy. We actually have a recursive calls counter in VDollar session stats, VDollar system stats, etc. So it's actually very, very easy to get by session level, and even at a statement level, how many recursive calls something has done. But just the presence of recursive calls does not necessarily mean something is bad. Let's walk through some examples. So for this demo, I'm going to create a table called T. It's just got a primary key, and I'm going to stick 5,000 rows into it, the primary key going from 1 to 5,000. Let's now do a simple query with a bind variable. Bind variables are good. They reduce your parsing costs, etc. So I'll declare a bind variable of B1, set it to the value of 1. For the rest of this demo, we're going to do a lot of before and afters so we can see what the delta is. So I'm going to look at my session stats right now for recursive calls. I've currently done it in the session 1767. Then I'm going to run this very, very simple query. Select star from T where X equals B1. It's a primary key lookup. It's using a bind variable. How many recursive calls? Before we started, it was 1767. After it was 1805. Yes, my SQL is too lazy to do the subtraction myself, but you can see it's about 30 recursive calls. That's because the database has never seen this SQL before, select star from T where bind variable, and therefore it had to go do some dictionary lookups to actually work out how to run what the table was, etc. It had to populate the dictionary case to actually know how to actually run that query. If I run it again, I should expect some sort of benefit. And I get a little bit, a tiny bit less, not much. I do get some because even though that has been seen, every query being thrown over the fence here by SQL Plus needs to be soft parse, and therefore there is still some lookup going on. Now we can reduce soft parsing, as some people know, using session case cursors, but that requires repeated executions of the same SQL. So that one still took about 30, just under 30 recursive calls. So let's do 100 of them now to populate our session cursor cache. Chung, chung, chung. They're actually all for different bind variables, just to prove they're not exactly the same, 95, 96, 97, etc. And you can see I ended up with what, about 130 recursive calls. 30 recursive calls for that final soft parse, and then only one recursive call for the actual execution itself. We ended up with 130 in total for 100 executions, 30 for the initial, and then 1, 1, 1, 1, 1, 1, 1. You can see our session cursor cache kicking in there. In normal operation, if you're running high frequency SQL with bind variables, even if you're soft parsing, you're probably going to expect minimal recursive calls. And that's what you should be aiming to see. In that case, in situations like this, where you're only doing good SQL, you would imagine recursive calls should be fairly low unless your shared pool's too small and getting a lot of parsing when you didn't need it. And therefore that's a good detection. Yep, recursive calls low, my application is doing well. Let's flush out the share pool and do some more experiments. My recursive calls is now at 7336. I'm now doing 100 distinct SQLs because I'm not using bind variables. You can see the recursive calls actually isn't as bad as you would think. Because the table called T is actually now in the dictionary cache and the columns are in there as well. Yes, it's a little bit worse. I've gone from 30 recursive calls to about 300, but it's 100 executions. So I went from 1 recursive call per execution to 3 recursive calls per execution. Every single one of these had to be parsed, but they were all parsed against the same table called T with the same columns. Therefore, all that stuff was already in the dictionary case. There's a parsing overhead for sure, but the number of recursive calls is not dramatically bad. And that's one of the things I wanted to reinforce here. If the recursive call count is low, that is not a guarantee that your system is using really intelligently written code. If all my code was being hard passed here, that is a nightmare in terms of CPU and contention and security. And yet the recursive call counts are actually quite manageable. So you can't assume that a low recursive call count means your system is running brilliantly. Let's check our before value again. Let's now do some really good SQL in Peel SQL. As we said, I'm a big fan of wrapping all your SQL in Peel SQL routines because you get that maintainability, guaranteed bind variables, modularization, etc. All the good things that come with Peel SQL. What do I get? A stack of recursive calls. This is not bad SQL and it's not bad code. What it is every SQL that gets run from inside a Peel SQL block is deemed recursive because the outer call is actually the Peel SQL block. Every call that comes from within it to the SQL engine is deemed recursive. So this is the opposite to the previous example. The recursive call count will be high if you have an application which has a lot of Peel SQL in it. That's not a bad thing. It's probably a good thing because you are actually using Peel SQL to drive your SQL statements. Having said that, let's create a little function here called getStuff. And what it is, you pass in a primary key and it goes and gets one of the non-primary key columns. I see this a lot in applications where people take a 3GL mindset. I have a key, look up some data, and they build functions in the database to mimic that. In of itself, that sounds like a good idea. I'm using Peel SQL engine to do these queries, and that's fine. If I call that, that's fine. But how often would I need to call this function if all I have is a primary key? If I had that primary key, I must have got it by querying the table. Why didn't I get the other data at the same time? The risk of functions like this is you start seeing people write code like this. There's my recursive call before, and they write stuff like this. I need to get the primary key, and I need to get some other data as well, so I'll call my function because that's what code reuse is all about, getStuff. Rather than just doing a straight select statement to get all the columns, they're now calling a Peel SQL function, which will do the same select statement anyway. So in this case, huge amounts of recursive calls, but they're not good recursive calls. SQL inside Peel SQL is normally good. In this case, where you're using Peel SQL where you didn't need to, the high recursive calls is a warning flag saying people are taking a Java-esque mentality into the Peel SQL engine. And it's a different thing. As I said, I'm just presenting these as examples as to where high recursive calls might not be bad, low recursive calls might not be good, and vice versa. And finally, hopefully you'll never ever have to encounter this where someone has a Peel SQL function and it's doing dynamic SQL without bind variables in there, because that's about the worst you can imagine. There's my previous recursive calls. Now I'm doing this, select this, doing getStuff, which in itself is going to use dynamic SQL, which is going to use not bind variables, therefore parse everything. And we did 20,000 recursive calls. So if you do see your recursive call numbers just insanely high, it's definitely worth a bit of investigation because sometimes things have gone hideously wrong. To answer the original question, it's easy to detect recursive call counts, but you have to detect the numbers, measure the numbers, and then conduct an examination of your code base, either in VDOLA SQL or in your source code control system to see, are these good recursive calls or are they bad recursive calls? Just the number itself, the measure itself is not a good enough indicator to decide whether you need to take some sort of reparative action.